This is shop talk. A snapped tap in a finished part isn't a tooling failure. It's a sync failure. G84 is one line of code that tells the controller to do 4 things at once. And when any one of them slips, the tap pays for it. G84 is the standard tapping can cycle on FANUC-style controls. You give it a Z depth, a feed rate, an R plane, and an RPM, and the controller is supposed to handle the dance between spindle rotation and Z plunge. A typical line looks like this: G84, Z minus ½ inch, R plus 1/10, F at the calculated pitch speed, S at your tapping RPM. Here's the thing most operators never get told. That F word isn't a real feed rate. In feed per minute mode, it's a derived number, RPM divided by threads per inch. In feed per rev mode, you just program the pitch. Get it wrong and the tap fights the whole way down. Rigid tapping means the controller electronically locks the spindle encoder to the Z-axis servo. Every degree of rotation maps to an exact distance of Z travel. There's no slack, and that's the whole point. On FANUC controls, rigid mode is commanded by M29 S-word, typically in the block before G84, though some setups take it on the same line or use a G84.2 format with no M29. It's parameter dependent. Without rigid, the cycle assumes a floating holder takes up the slack. Floating tap holders are the mechanical version of that forgiveness. The tap sits in a collet that can extend and compress maybe 1/10 of an inch in either direction. If the Z feed drifts off pitch, the holder absorbs the mismatch instead of the tap. Rigid trusts the math. Floating forgives the math. Here's the aha most people miss. In rigid tapping, Z is slave to the spindle encoder on both the plunge and the retract. They can't decouple by design. So taps that break on the retract aren't losing a timing race. They break from chip packing, a dull tap, or a spindle that physically can't follow the commanded sync. Picture it. Bottom of the hole, the controller reverses spindle and lifts Z as one locked pair. In healthy rigid mode, they stay synced. But if following error climbs under load or heat, the spindle can't keep up. The tap winds against threads that aren't unwinding fast enough. Failure Mode 1. Spindle acceleration. Small machines and older spindles can't ramp from 500 forward to 500 reverse fast enough to match the programmed feed. The controller doesn't know, it just executes. And this is where I'll get hate mail. Most snapped taps aren't a tooling problem. They're a sync problem the operator inherited from a post-processor nobody audited. The G code looks fine. The machine is the wrong tool for that code. Failure Mode 2. Chip packing. Standard G84 plunges to depth in one shot. In a blind hole or a gummy material, chips have nowhere to go. They pack at the bottom and resist the retract. That's where PEC tapping comes in. On FANUC, PEC rigid tapping runs off the standard G84 line. You add a Q-PEC depth, and a parameter setting breaks the plunge into segments, retracting partway to clear chips. Don't assume G84.2 means PEC. That code varies by control. For blind holes in aluminum, pecking is the difference between a clean thread and a broken tap. Failure Mode 3. The pitch math. Imperial taps feed off threads per inch. Metric taps feed the pitch in millimeters per rev. The trouble comes from the wrong G20, G21 mode. We're treating a TPI number as a pitch. Get that wrong, and the tap snaps on the first hole, and you'll blame the spindle. So when do you pick which? Use this decision. If your spindle can ramp fast and you trust your post, rigid wins on accuracy and cycle time. If you're on an older machine, a high-load material, or any setup with stack-up uncertainty, floating saves taps. And a quiet rule. If you're switching a proven floating tap program to rigid to save a few seconds of cycle time, dry run it 3 times before you trust it. The sync error doesn't show up on the first hole. It shows up on the 100th when the spindle is hot and the servo's drifted. If you've made it this far, you already know more about G84 than most operators running it daily. Subscribe. We break down the codes, cycles, and shop floor failure modes nobody covers in the manual.